My name is Dan Perkins. I work for Rohde Schwarz. I'm a national applications engineer, specifically supporting our over-the-air test systems. So today what I wanted to talk about was our legacy assisted GPS and LTE location-based services. For this we use a couple different components. We would use a CMW 500 as a network emulator, and then we would use an SMBV 100A, which is our satellite simulator. And what we can actually do is we can simulate not just the American constellation, but we can also do GLONASS. We can do GNSS, the entire Beidou, Galileo, all the constellations, and their hybrids. So for OTA testing though, what I would have to do is, because I'm doing assisted GPS, I'm actually going to have to not only get in a call. The call itself is just a transport method for the assisted messages, but the satellite simulator is going to be doing those measurements. So we're going to be using a control software that's going to be speaking to the device over a call, and we're going to be getting those carrier noise values from the device under test. So for our OTA system, our primary control software is AMS32, and then AMS32 would be remote controlling another component, which is that positioning determining entity, tying the network and the satellite simulator together. So right now I just have it in demo mode. I'll just go ahead and play in demo mode. Of course it'll be in super speed, but then we can talk a little bit about what that data looks like. So in this case, I'm emulating a GSM call, a GSM 850 call, and I'm actually collecting carrier noise. I'm getting the carrier noise from the baseband of the chipset or the device, and I'm basically plotting this at each azimuth and elevation as I rotate the device in the anechoic chamber for both polarizations. Once that's complete, I'll go ahead and go back to the peak in the upper hemisphere, and I'm going to go ahead and do a linearization. So again, I'm going to set a fixed level, get the reported carrier noise. That carrier noise would tell me, okay, at a satellite level of say -130, my carrier noise is at 43. I'm going to step in 1 dB increments to kind of pick up any error in the linearization of the device itself. Once that's complete, then I need to do a statistic, a step approach to find sensitivity. So I would step in 0.5 dB increments, looking for 95 good measurements out of 100, and that would tell me what my assisted GPS sensitivity would be, or my total isotropic sensitivity. Because we're using callbox, we're actually using real-time signaling, so we can collect the measurements much faster, and of course save our customers quite a bit of money, because they're only buying call boxes and signal generators, which most of them already have in their labs already. So with that, if you have any further questions, you can always go to our website. It's for rohde-schwarz.us, and thank you.